Okay, we're going to start by reviewing how to find limits graphically. To begin, we need to go over some notation. So this is talking about the limit of the function as x approaches c. Now c is just some x value of interest. What's being implied here is that x is approaching c from each direction. Now that means from the left and from the right. Next, we see this notation. You see a little negative after that c. That means we are approaching it from the left only. Now, if we are approaching it from the left, what that actually means is that we're moving to the right on the function, getting closer and closer to our x value of interest. And finally, if you see a little plus after the c, that means we are approaching it from the right. So if we are approaching our x value of interest from the right, we're actually moving to the left on the function. Now these last two are known as one-sided limits because we're approaching our x value of interest from one side only. Now keep in mind that a limit is simply a height, and by that I mean a y value. So in these limit problems, when we're looking to find the limit graphically, we need to look at where is the y value, what is the height that the function is approaching as we approach our x value of interest. So whether we're approaching it from both sides or just one side, we're simply asking ourselves the question, what is the height that we're approaching? Okay, down below here we have an example of a function, and I'm just going to label this f of x. This should have been done already. So the first few questions here deal with an x value of interest of -2. So -2 is over here. So we're first looking to find the limit of the function as x approaches -2 from the left. Now if I'm going to approach it from the left, I need to be moving closer and closer to it on the left-hand side. So as I get closer and closer to -2 from the left, my height is 2. You can see right up here at the end, the height is 2. Next, we're looking to find the limit as x approaches -2 from the right. So now I'm to the right of it and moving to the left, getting closer and closer to -2. And as I do that, I'm looking to find what is the y value, what is the height. Well, we can see from our function that it's -1. Now don't be confused by the fact that there's an open circle there. This is a very important point, so we're going to have you jot this down off to the side. A limit can exist at an open circle. Okay, so a limit can exist at an open circle. Please jot that down. So we're now asked to find the overall limit as we approach -2 from each direction. Well, we saw that in the previous couple parts here that from the left it was 2, from the right it was -1. Because those do not match up, we say that our overall limit does not exist. Okay, if they were the same value, then our overall limit would be that same value. But because they're different, the limit does not exist. So DNE. And finally, we're looking to find f of -2. Now this is not a limit question. This is simply saying what is the y value when x is -2. This is where we care about, is it open or is it closed? It's the only time we care about that. So up here at +2 we see a closed circle. So that is my function value. It's not going to be at -1 because it's an open circle. Okay, so now our x value of interest is switching to 0. So this is where x is 0. And if we look at our function here, we want to approach it from the left, from the right, and then from each side, and then identify the function value. So first, as we approach 0 from the left, we're getting closer and closer to 0 from the left. We can see that our height, or our limit, or our y value, is 1. Likewise, as we approach it from the right, our height is 1. As we approach it from each side, since the two one-sided limits are the same value, the overall limit as x approaches 0 is that same value of 1. And notice how we have a closed circle there, so the function value is 1. Now anytime the limit value equals the function value at a point, we can say that the function is continuous or unbroken at that particular point. Okay, and finally, we're going to look at an x value of interest of 3. So we want to approach 3 from the left, and then from the right, and then overall. So as I approach 3 from the left, as I get closer and closer to it, you can see that the y value is 0. As I approach 3 from the right, as I get closer and closer to it, we can see that the y value that time is 0, which makes the overall limit 0 as x approaches 3 from each direction. Finally, f of 3. Again, we're not looking to find a limit here. We're looking to find the y value when x is 3. So this is where we said, is it open, is it closed? Well, right here, we do have a point where it is closed, which means it's defined. So f of 3 would be -1, because that's where it's clearly defined. It's where it's closed. Okay, we have another function here. It's a more complicated looking function. We have some vertical asymptotes built into it. Well, we have one vertical asymptote and one horizontal asymptote, I should say. And we have some questions here that go with this function. First of all, trying to find the limit of the function as x approaches -5. So this is where x is -5. So as we approach -5 from each direction, notice we have a hole, but that's okay. A limit can exist at a hole. The height of that hole is 2. So the limit as x approaches -5 from each direction is 2. Next question here is asking us to find f of -5. That's asking us for the y value when x is -5. Well, there's no filled in circle, there's no defined point, so that means that the function value f of -5 does not exist. Okay, again, we don't have a place where it's defined or closed. Next here, we are looking to find the limit of the function as x approaches -2 from the left, and then -2 from each direction. Well, -2 is where we have our vertical asymptote. So here is my -2, okay, for x. As I approach it from the left, it means I'm getting closer and closer to it from the left-hand side. Well, the height appears to be going up forever towards infinity. So we say that our limit value would be infinity as x approaches -2 from the left. Now, as x approaches -2 from each side, well, we have to look at from the left as well as from the right. Well, we just said that from the left, the limit would be infinity. Well, from the right, it would actually be -infinity since it's going down forever. Since those two one-sided limits don't match up, the overall limit does not exist. Alright, next we're looking at an x value of interest of 1. First we want to find the limit from the right and then the overall limit. So let's go back up here. This is where x is 1. So as we approach 1 from the right, we're getting closer and closer to it from the right. Yes, there's an open circle there, but that doesn't matter. We are simply concerned with the height. 1, 2, 3, 4, 5. It appears to have a height of 5 as we approach it from the right. Now, overall, as we approach 1 from each side, that's going to be does not exist, because if we were to approach 1 from the left, the limit there would be 2. And 2 and 5 are a mismatch, so does not exist would be our limit. Next, we have an x value of 4 that we're interested in. So we're approaching 4 from each side. So this is where we have 4 in our graph. Okay, it's right there where we have that open circle. As I approach 4 from each direction, we do converge to a common height, and that common height is 3. F of 4 is asking for the function value when x is 4. This is where we're looking for a closed circle. We can see that that happens at 1. And finally, we have a couple questions that deal with x approaching infinity and then negative infinity. So first, if x is approaching infinity, that is the extreme right side of your graph. Ask yourself the question, what's happening to y as x gets super big? Well, y is approaching 2. And finally, as x approaches negative infinity, so as x gets super small, what's happening to y? Well, this is the extreme left side of the graph as x is getting super small. What's happening to y? Well, this appears to be going up forever, so that indicates that our limit would be infinity. So infinity would be our answer for that.